In this video, we're going to explore what redshift is and also how the Big Bang occurred, which are both quite complex topics, but very important in understanding our universe. The central idea is that from our vantage point here on Earth, when we look out into space in every direction, the galaxies appear to be moving farther and farther away from us, or to put it differently, the universe itself is expanding over time. The main piece of evidence we have to support this conclusion is something called redshift, which is the redshifting of light coming from very distant galaxies. The underlying explanation for why the universe is expanding lies in what we call the Big Bang theory, which we will also look at. Now, to really understand what redshift is, we first need to understand the concept of absorption spectra. Imagine a box showing the absorption spectra for visible light, which is the light emitted by the sun, and then observed here on Earth. On the left side of the spectrum, we find the longer wavelengths of red light, while on the right side, we see the shorter wavelengths of violet or purple light. All of these wavelengths are emitted by the sun and travel toward Earth, but along the way they pass through the sun's atmosphere, which contains a variety of chemical elements. Some of these chemicals absorb specific wavelengths of light. For instance, oxygen molecules might absorb certain parts of the spectrum, while hydrogen might absorb others, and additional chemicals will absorb still other wavelengths. As a result, by the time the sunlight reaches us here on Earth, some specific wavelengths are missing, and when we look at the absorption spectrum for visible light, it appears as a continuous spectrum with a pattern of dark lines where the light was absorbed. This unique pattern is like a fingerprint for the light that left the sun. However, when we analyze light that comes from distant galaxies, we notice something different. The pattern of black absorption lines is still present, but the entire pattern has been shifted slightly toward the red end of the spectrum. This phenomenon is what we call redshift, and it occurs because the light waves become stretched during their journey to Earth. For example, if a particular gap in the spectrum originally appeared at a wavelength of 600 nanometers, by the time it reaches us, it may have shifted to a wavelength of 650 nanometers. This stretching of the light waves causes all the absorption lines to appear at slightly longer wavelengths, which results in a shift toward the red end of the spectrum. The simplest way to understand this redshift is to think that the galaxies emitting the light are moving away from us, and as the light travels toward us, the waves get stretched. However, the situation is a bit more complicated than that. The galaxies themselves are not actually moving away from us by physically traveling through space at high speed. Instead, what is really happening is that the space itself between us and the distant galaxies is expanding. Because this space is getting larger over time, we end up being farther away from those galaxies, even though they are not moving in the traditional sense. To help visualize this, we can use a model involving a balloon that is covered with small dots or markers, where the balloon represents the universe and each marker represents a galaxy. As the balloon inflates, which symbolizes the expansion of the universe, all the markers get farther apart from one another. The key detail here is that the markers themselves do not move across the surface of the balloon, rather it is the surface of the balloon itself that is stretching. So if we were a galaxy located at the center of this balloon, it would appear to us that all the other galaxies are moving away, even though it is really the space between them that is increasing. Another interesting and important observation is that the farther away a galaxy is from us, the faster it seems to be moving away. This means that the most distant galaxies are the ones with the greatest redshift, and they appear to be receding from us at the highest speeds. However, whenever we use models like this, we must remember that no model is perfect. For instance, balloons can only stretch so far before they burst, whereas our universe is not expected to burst. Also, if the balloon truly represented the universe, then galaxies would exist throughout the inside of the balloon, not just on the surface. Despite these limitations, we continue to use such models because they are helpful in explaining and understanding complex scientific concepts that might otherwise be difficult to grasp. Now, let us consider one final question: how did the universe begin in the first place? If the universe is expanding now, then it is reasonable to think that in the past it must have been smaller. If we keep tracing this expansion backward, we eventually reach a point where the universe must have been incredibly tiny. So the big question becomes, how does something so small expand suddenly to become a massive, ever-growing universe? The honest answer is that we do not know for sure, but we do have some strong and scientifically supported ideas. The most widely accepted explanation is called the Big Bang theory. According to this theory, all of the matter and energy in the entire universe was once concentrated in a single extremely small point that was unimaginably dense and hot. Then suddenly, there was an enormous explosion and space itself began to expand outward in every direction, and this expansion has continued up until the present day. That brings us to the end of this video, and we hope the explanation made things a bit clearer for you. If you enjoyed learning with us, then please consider telling your friends, and we will see you again very soon in another video.